Assalamualaikum warahmatullahi wabarakatuh. Right. I hope you guys can see my screen and you can scan. Can you guys see my screen or not? And yeah, sorry, I forgot. Okay, can you guys see my screen now? The lecture. Boleh nampak? Anyone? Because I don't know what's wrong.
Boleh.
Boleh ya? You can see the lecture slide ya. Because I don't know what's wrong with Microsoft Teams. Because I cannot see anything in my desktop. Because normally I'll be able to see in my desktop whatever display in my iPad. But I don't know why I cannot see. Somehow because they have added new features in the Microsoft Teams. So somehow rather I cannot see my iPad screen on my laptop. Okay, but we still proceed as long as you guys can see the slide should be okay. Right. Okay, so can scan for your attendance. Okay. Just make sure you can scan it. Right. So I just want to remind you guys about your attendance. Okay. So because I have checked your attendance, there are still students who didn't scan at least minimum 2 times. There are still students who didn't scan at all, means don't have a record. So I will put your attendance in the OneNote for you guys to check. Okay, so if I miss anything, so you have to let me know, especially your attendance, because you have to aware this is very crucial since that what we call that because it's your attendance, because it's a proof that you are participate in this online class. So if you didn't participate at all, so then it will be it will be an issue later on. You don't want to create any issue later on. So please at least I try to be as flexible as possible, but then I will also need your cooperation to make sure that at least you'll be able to participate. Okay, just scan when you do your assessment, when you watch the video back, or you do what you call assignment or quizzes or tests, and also just try and scan the QR code. Okay, and if you look into the lesson plan, supposedly this week we have quiz, so the quiz has been postponed to after Raya. But please be aware, after Raya it will be like it will be quite packed schedule, because we have I think if I'm not mistaken, we have assignment that we're going to be released. We have one quiz, okay, and then also we're going to have tests, okay, another test. So please be aware of that. Okay, what we call what else? Okay, I think today we're gonna continue with our lecture, which is last time we have stopped at we have go through the lecture part of the shear strength, how to design. So today we're gonna go through the examples. Okay, all right. So just to recap back what we have go through last week. So at this point, you should be able to identify where is the position of the crack, occurred by shear, okay, for a pre-stressed beam or for a beam, right? So you identify which part is the flexural caused by bending and where is the caused by shear at this point. And you also be able to know what will be the effect of the tendon to the shear to the beam in terms of shear. Okay, what will be the effect of the tendon itself, right? And when you design or when you want to check for your shear, okay, either you want to provide or not. So there are 3 conditions to be considered. First condition is whereby your section does not require any shear reinforcement. So second condition will be your shear, what we call that, still no shear reinforcement for uncracked region, means you are considering the region will be uncracked, okay, for region in bending. And the third condition is whereby you have to provide your shear reinforcement. So there are three conditions that you have to consider, right? So each of the what we call the condition. So you have your the the equation or the minimum. For example, does not require shear reinforcement, so you have to provide the minimum shear reinforcement. What would be the formula to calculate the VRDC, the Vmin, okay, the VRDC. Anyone who want to check your resistance against your actual design or actual shear. And for the uncracked in bending, okay, for the second condition whereby you're calculating your VRDC, okay, for second condition, right? And what we call that, when you're calculating the area. And for the third condition is where your shear reinforcement is required, and then you have to calculate what will be your maximum resistance will be, okay, right? And the angle. So this value where you choose which one is the critical shear. And yeah, so your tangent or your theta for your slope for your for your beam, you will consider it between 22 degrees and 45 degrees, okay. And what else that we want to highlight before we proceed with our example? Okay, and vertical shear reinforcement, where you get the ratio of your area of your link divided by the spacing. Okay, additional longitudinal force. Okay, so where using this method you provide it in terms of the support. Okay, to provide extra support in terms of the to cover the shear. And the summary of this design, whereby at step 2, whereby you decide either you require shear reinforcement or not. So if not, then you will go straight to the step 5. If yes required, then you go step 3 and also step 4 one by one, okay, until you end up with a proper what you call designed shear reinforcement. Okay, then it comes to this example. All right. Okay, so let's start with this example, shall we? So I will release an assessment later on, okay, on this particular examples. Okay, so please take note. Really sorry about the diagram. The diagram is a bit off here. I mean, it's not clear. I don't know why. Because the slide before should be alright. It's supposed to be the drawing should be. The line is not as blur as this, but somehow when I open it today, it appear like a bit blur. Okay, somehow like that. It's an I section beam. So figure shows the cross section of beam with a constant parabolic tendon profile over 30 meter span. Okay, the span of the beam is 30 meter. The eccentricity of tendon varies between 300 mm at ends and 750 mm at the mid span. So means that if say that you have 38 meter span of your beam, say that this is your 30 meter span. Okay, so here you have the drop of your 300. This one is 300 at the end, and then you have a drop of 750 mm at the mid span. So your drop is something like this for your tendon profile. Okay, for your tendon, yeah. And the beam supports an ultimate uniformly distributed load of 40 kilonewton per meter, which is the UDL is 40, and your concrete strength is 35 MPa. Okay, so the pre-stress force after losses means after you multiply with K is 2,590 kilonewton with your initial moment of inertia with your area of your whole section. Okay, 400 times 10 power of 3 mm square. Your tendon area, which is 3,450, and your strength for your steel, and also the tensile concrete strength, which is 2.3. Okay, alright. So at this point for your beam, we consider only 15 meter because of the the symmetry section of your beam. So we only consider half of it, okay, in our design. Alright, let's take a look. So in terms of calculating your VED, or your actual shear stress or shear force, okay, which is WL/2, okay, you get 600 kilonewton here. Okay, you get 600 kilonewton here, right? By considering your 40 UDL, 40, you this given here, this one 40 kilonewton per meter. Okay. Check if shear reinforcement is required. So how to check, how to know shear reinforcement required? We can use this formula. Okay, so means that you have to understand what is K, what is rho 1, okay, what is your stress. So you estimate your D, okay, your D in terms of your position of your tendon, which is calculated here from this point to the center point of your tendon. So this is your, particularly your D, okay. 200, so you have 850, okay, and until you get 950 lah, okay. Alright, so that's your D. Then you get your K. Once you get your D, you can calculate your K, which is 1.46. Okay, check it's either bigger or lesser than 2. Then you have your rho 1. So you have your ASL, which is, this is your AP, your tendon area, multiply with the B, which is your width of your B. Okay, and multiply with your D of your effective depth, then you have 0.0242 when you calculate it. But somehow rather, when this is bigger than 0.02 as stated in the standard, so you will take 0.02 instead for your rho 1. Okay, and you have your stress CP, which is your stress CP multiplied with your partial factor of safety for your tendon. Okay, multiply with your P naught, which is already it is already considered the losses, which is 2590, divided by the area of the section of your beam, okay, which is given as 500 times 10 power of beam. So your stress will equal to 4.66 Newton per mm square. So obviously this is what we call that, when you multiply this and this, you also still get 4.66. So the condition is considered okay. Alright, so you put everything in this formula here, then you calculate, you shall get 202 kilonewton for your shear resistance. Okay, shear resistance, this shear resistance is actually solely coming from the section, alright, from the section. Okay, so also from equation 6.4, so this is the first, what we call the first condition you consider. So this is coming from the second condition where there's no crack, uncracked condition, okay, and you have your BW multiplied with I and divided by A Y bar. So at this point, you have to estimate the theta, okay, because you want to consider what will be your, because it's a what we call contributing from the tendon. So your stress CP is given, alright, as what you calculated before. It's already calculated. Your tensile concrete strength divided by the partial factor of safety for materials, for concrete material 1.5. So alpha 1 is equal to 1 for post tension tendons. We don't, the question doesn't really mention is it the post or pre, but we are referring to the, I think the previous example has mentioned is a post tension, so we proceed with post tension. Okay, and your resistance, okay, your shear resistance, when you consider this equation, okay, so you calculate, for example, like here is BW multiplied with the I. Okay, so it's very straightforward lah. Alright, so you have your B and also your I. And for your A, multiply with your Y bar, this is a bit, you have to check, you have to try and do it yourself. Okay, generally you have like your, what you call that, if you look into the section, okay, so this is your neutral axis. Okay, this is your neutral axis. So y bar, so you have two different sections here. You have this section area. It will be one section because the y bar will be somewhere here. Okay, and then you have a second section will be at this point whereby you have it somewhere here. Okay, so you have to total up the area. So you will have this area, the big one, multiply with this, the small one. Okay, try and do the the calculation plus or minus and all, and then try and see if you get it or not. Okay, 147 square plus with 1 multiply with 4.66 multiply with 1.47, which is your FCTD. Okay, at this point. Okay, and then you shall get 500 kilonewton for your resistance caused by the your uncracked condition. Okay, so you compare these two, then you get your resistance. You take the critical one. The critical will be 202 kilonewton. So once you get 200 kilonewton, you look into because the position of the tendon given at the end span, which is 300, and then at the mid span it goes down to 750. Okay, so with this you can estimate what will be your inclined tendon. Okay, inclined tendon means that directly from the tendon, what will be the force. So by considering what will be, what will be your beta. So in a way, you have your x is equal to 15. So at this point, we consider it goes here, x is equal to 15. Okay, and then your y is the difference between 750 minus with 300, which is you get about 450. So in a way, if you use the parabolic equation of the tangent profile, you will get your c is equal to 2 times 10 power of minus 6, and your y is equal to 2 times 10 power of minus 6 multiplied with x squared. So when you differentiate to know what will be the slope, and you will get it 26x, and you multiply, then you get your tangent beta, and you can conclude your beta is around 3.43 degrees Celsius, 3.43 degrees, and this is like equivalent to more or less, tangent beta, which is 0.06, okay, more or less lah, right? If you punch the calculator, you will get more or less the same. So your tensile, what you call your tendon shear force will be equal to 155 kilo Newton. So when you want to know your total shear capacity, generally you will add these two forces coming from your section, your beam, and also coming from your tendon. So you plus with the partial factor of 0.9, then you can conclude it's around 342 kilonewton, right? So you will compare with what that the UDL load applied on the beam, which is 600. Obviously, it's bigger than 342 kilonewton. So once you calculate this, you can conclude that shear reinforcement is required, since that the applied is 600 kilonewton. What your beam can only sustain with the tendon is only 342 kilonewton. So this is the first conclusion we make. Alright, any questions so far? Soalan? Anyone? Hairunisa?
No, I didn't.
Rina? Anyone? Supri?
Tak ada, madam.
Yeah? Okay, tak ada lagi. Alright. Okay. So I proceed. Okay. So once you know that your shear reinforcement is required, then you have to proceed to estimate what will be your shear resistance maximum. Okay. So for the shear resistance maximum, you proceed with the third condition. Okay. And this formula that you use, you assume that your cotangent theta is 2.5, whereby your theta is equal to 22 degrees. Okay. And at this point, when you calculate your shear resistance maximum, you have to find out your alpha W, alpha CW. Okay, whereby if you look into the formula back, okay, where is it? Okay, Right, in terms of this equation, you have your alpha CW, which is equal to 1 if it's a non-pre-stress. But then if it's a pre-stress, you have to consider these three conditions of your stress tendon. Okay, tendon of your stress. Either the limitation, which one the limitation fell, then the value of alpha CW will rely on that. Okay, will depending on that. So we will do the same for the examples. Okay, and you have your what you call that, your stress CP. Okay, which is you calculate it and then you should get like 4.66 Newton. Please remember that your P naught given is already multiplied with losses, so no need to reconsider that. And then you will have like stress CP divided by FCK, which is 466 as what you calculated, divided by the concrete strength, which is around 0.13, which is less than 0.167. Okay. Alright, so then you will get your alpha CW. Okay, you try again, then you will get the value will be equal to 1.2. So you put it inside the formula, you should get your resistance around 638 kilonewton. So in terms of crack condition, your shear reinforcement is considered okay because it's bigger than your applied force. Okay, applied force, applied shear force. Okay, all right. Okay, that one in terms of that. Sorry, excuse me. All right. So area and spacing of links, all right? So you have the ratio. Normally, it's very common. I think the same application that you use for RC, okay, for your RC, whereby you use the ratio of your area of your link divided by the spacing of your link. Okay, so in this case, we are considering this as your the ratio. You include the value of your VED, but you have to remember you minus with the force contributed from your tendon, which is 155 minus times 0.9. So then you will get your D and your your strength cotangent by considering tangent theta is equal to 22 degrees. You will get 0.497. Okay, so 0.497 for your ratio. So in terms of calculating minimum link, to get the ratio, you will use this formula for the minimum link and multiply, very quite straightforward, then you will get 0.14 here. For the 0.14 ratio is only for minimum link. Okay, so in a way you provide 10 mm links at 300 mm centers, which is considering that when you use this you will get it around 0.523, which is sufficient enough for your your ratio of 0.497 where you have calculated. Okay, so provided is 0.523. So in this case, normally it's a ratio is depends on your situation. You might want you want to choose the spacing and fix the area, or you fix the area, you choose the spacing or something like that. Okay, vice versa. Right, so then the V mean, okay, the minimum length you can calculate by considering 0.78 multiply with D FYK cotangent theta, you will get around 484 kilonewton. So the minimum length that you can provide is around that value with this dimension, with this provided dimension, which is 400. Then you get your V mean 484. Okay, all right. So if you look into your that one with your 484, your minimum lah. Okay, calculate your additional longitudinal force, right? So you want to add more reinforcement, okay, and you calculate it by putting the VED and cotangent theta, right? Then you have like 0.9. Okay, multiply with 155 for your VED, for force intention, for tension. Multiply with 2.5 for cotangent theta, then you will get 575 kilonewton. Okay, So for 575, your area of your steel, okay, for your link, you can consider by taking your force 575, okay, divide by 0.87 multiplied with 500, so you will get the area is around 1,222 mm. Okay, so means that that will be the area for longitudinal force. So you can provide, okay, based on the table of dimension, table of dimension for the bar, you can estimate. So the area is around 1,960 mm square. So at the bottom of the beam construction, so need to check at each section if need longitudinal reinforcement bar or not. Okay, so here when you wanna place your reinforcement, say you have I-beam like just now, okay, you know that there's already a tendon provided somewhere here, okay. Alright, so now question is where you want to locate your four untensioned 25 mm bar. Where you want to allocate, okay. The allocation of the four, it could be done like somewhere here. It means it will be one layer. Alright. So once you want to place your reinforcement, you cannot just simply place as you like. Alright. You have to make sure that the position of where you place your tendon is sufficient in terms of fulfill all the requirement. Okay. Alright, so say that you have four, just now you provide 4H25. So it looks okay for this section because say that the section is 175 for the height. Okay, and you have this one is 25. Okay, so in general how you calculate is say you calculate 175. 175 minus with 25, then divide by 2. So in a way, you have the gap here is around 75. So which is okay because normally for the beam, you have the cover between 25 to 30. So around 75 minus, we say that we take 30, which is we have 45 mm gap. Is it okay? I mean, in terms of mathematical sense, it's still okay because we consider like the minimum aggregate size will be 20 mm. So as long as the aggregate can pass through your reinforcement and also can pass through in concrete, then it should be okay. The problem happen when the water cannot flow properly. So when the water cannot what we call that what did I say just now? Okay, sorry. I mean, when the water cannot flow, when the concrete cannot flow properly, when you pour in the concrete, then the gap, if say that the gap is like too, what we call too narrow, right? Because you don't allow spaces. For example, you have like your beam like this, and probably you put your 4 bar somewhere here like this. Okay, and say that you have like this one is 25 25, okay, and here is like maybe 175. So you look at 25 is 50, 175 minus 50, okay, then you divide with 3, right? So here you have like here if I'm not mistaken, 175 minus 50 divide by 3, 175 minus 50 divided by 3. Okay, so here you will have like 40, 41 like that. This one is 41, still 41. Okay, so it's still considered okay because you have like 41 is like slightly above 30. Okay, and and the water and the concrete can still flow when you pour in the concrete inside, and then especially when you have the aggregate, the minimum size of the aggregate like 20 mm. Okay, so as long as you can flow okay within the reinforcement, is still okay. But if you say that you have like 150, so 150 minus with 50, Okay, minus 50 just now. Oh, sorry, 150 minus 50 divide by 3. So you get here it will be like 33. So if say that your cover is 30, you have like 3 mm. So you know how small is 3 mm. You know, if say that the gap is only 10 mm, pun you know how much is you know the gap will be. So only like a 1 centimeter gap. So it's very small. So when you want to place, that's why it's very important. When you want to place your reinforcement, regardless it's a reinforcement or you want to provide reinforcement or you want to provide tendon whatever. So it's very important for you to have the sense of dimension as well, where you want to locate by considering the thickness of your beam and also your width of your beam. Is it enough or not? Is it sufficient or not? You know, because you have to always obey with the maximum aggregate that your structure use. But it also depends because your structure doesn't always use 20 mm aggregate size. Sometimes they might use smaller than that, especially you know when you are using like ultra high performance like that. So normally the aggregate will be very small because they are using like a we call like a chipping aggregate, which is normally the size will be 10 mm like that. So it's very small. So if that is the case, then you don't have issue if you want to arrange your reinforcement like you know quite close to each other or only have like you know the gap between like 10 to 20 like that. So because as long as your aggregate can pass through, then it should be okay. The issue is when you place your reinforcement, when the aggregate cannot pass through, then there will be an issue because there will be segregation of the you know concrete when you try to put in concrete. Okay, so that's why I want to just highlight the importance of you know when you provide your reinforcement, when you add it in your beam. Okay, any question on that before we proceed? Supri,
Tak ada, madam.
Syafika, okay,
Okay, madam.
boleh ya? Balkis, okay?
Okay, madam.
Jacqueline, okay? So okay, I hope okay. Alright. So we proceed. Okay. Alright. So what you see here, in this table, okay, is what you have to because we are considering that you know the behavior of your what we call that the behavior that the of your reinforcement that you provide along the beam. Okay. Where is it just now? Okay, because what you calculated as you get like for example okay, okay, so what you calculated just now in previous using you know in the slide is this part, you know, where you consider the beam is at the end span which is 15 meter. Okay, so in a way you have it like along the beam. So this will be like your at your end span, which is considered as 15 meter, and then this is will be 0 meter from the mid span. Okay, this will be end span, this is will be mid span. So it will be like you know the other way around lah actually. So what you calculate before is at the end span, which is here. Alright, which is you get your maximum shear what we call that end span of your shear force, okay, which is kat sini where you have your x is equal to 15, okay, your mid span is equal to 0. Alright, and you have your d is 950, which is your effective depth, and then what you have calculated before for your resistance you get 202, and your pre-stress that you calculated when you multiply with your tendon force, which is 140, and your VED that you calculated is 600, and your VRDC plus with your tendon force, which is equal to 342, and your maximum resistance is 638. Okay, so if you look in terms of this, you have to come up with this table to know what will be your condition throughout your what you call the length of your beam from the end span to the mid span. Okay, so of course you will get it slightly what we call a lower force, because the maximum force will happen at the end span. Okay, so at this point, for example, like this table, they do let interval of 3 meters. So 3 meter, you have 6, you have 9, you have 12, and then you have 15. Okay, 15. So we start, sorry, I think I got it the other way around. It's supposed to be like 0, 3. Okay, it's supposed to be here 3, 6, and 9, 12, then you get here 15, right? Okay. So at this point, so it should be like this way lah, your x. Okay, because it started from x is equal to 0, means it starts with x is equal to 0 at mid-span. Okay, so what you do is actually once you have your, because you will see your d will differ. Okay, your d value will differ as your what you call your section your length, the length is differ. So means at 0 your d is different, your at 3 meter and 6, 9, 12, and 15 your x your d value, your effective depth will be differ. Why? Because it's according to the tendon profile. Okay, because your tendon is slightly bent, right? You have a certain profile of the bend, the tendon. So you will know, because at end span, the how much is the, because you don't what you call the deflection is how much, and also it will affect the position of your tendon. Okay, so you will see that at the mid span and also at towards the end span the value, and your VRDC. Okay, your resistance, once your D is different, and of course it will affect your VRDC values. Okay, because you will have the force for each what you call that resistance. Okay, at each position of your x, starting from 0 towards to 15 meter, and your value of your pre-stress also differ. Okay, based on your position of your x. Okay, and then you will get the value and increase, and your VED also differ because you have your WL. So L you will have it change, 0, 0, when 0 is 0 lah, because your L is 0. Okay, and then also it's differ the value towards 15, and you have your resistance. Okay, plus with the VT, of course you just this one lah, resistance plus your VT, the value that you get here. So 28 281 plus 0, then you get 281. So this value increase as the value here change increase. And the maximum resistance, okay, according to the formula, of course you have the value of your VT value here is different. Of course this one also you have it differ as well. Okay, so if you look, what you have to decide when you get this table plotted, okay, throughout the length of your beam. So you want to decide either which part that you want to provide your minimum reinforcement and which part that you want to provide reinforcement. Okay, especially to carry shear force lah. Okay, so what you will do is actually you will compare and see at these two value, because you look at the VED, which is the applied load, right? Say that the applied load for at 0 is 0, 120, 240. So this is the actual shear force. Okay, and then you compare it basically with what you get from what we call that from here, which is the what we call the resistance given here is sufficient enough, which is your this is 0 to 281. Okay, so your resistance is enough. So 306 is bigger than 120, which is bigger, and 325 is bigger than 240. So when you have it bigger, your resistance is bigger than what is actually applied. So then you only you only will provide only the minimum reinforcement, because you do not need any additional reinforcement. Okay, the thing happens change since started from your when your your length of the beam more than 6 meter. Okay, at this point when it reach 9 meter, okay, whereby you will see that your VED is increasing towards the end span, which is 15 mm, 15 meter, sorry. So at this point, you will get it increase up 360, 480, and 600. And when you see that, you will compare it with this value, and this value getting smaller. I mean, not really smaller in terms of what, but then it's smaller than the what we call the applied force or the applied shear force. Okay. So here you are 339, which is smaller than this, and then 346 smaller than 480, and 342 is smaller than 600. So once you see it's smaller than you will conclude you have to provide shear reinforcement. Okay, so you will provide, it means that you will not provide the same size of your link throughout the length of your beam. So you will identify which part only critical whereby you have to provide the shear reinforcement. So the part that is not critical, you just provide minimum shear reinforcement. Okay, so as what we conclude here for column 4, 5, and 6. Oh, sorry. Okay, for column 4, 5, and 6, you have it like ASW over spacing, which is the ratio where you have to provide your shear reinforcement, and then this will be when you want the minimum shear reinforcement. Okay, so minimum you can assume providing the same because it's 0 because it's the same minimum, but for the where you want to provide shear reinforcement, okay, it will differ based on the value that you have calculated lah for your resistance. Okay, and then this is the force of longitudinal force that required for the section. Okay, so you sketch this what we call that this diagram, okay, to see from 0, 3, 6, 9, 12, and 15, which is at the end span, which is where your what you call your maximum maximum shear force will happen. And from 0 to 9, you will consider providing only the minimum. Okay, and then at this point from 9 to 12 you provide 10, and then at 12 to 15 you provide 10 with 300. So you have more critical closer at 300 from 12 to 15, whereby it's getting when the shear is throughout the maximum shear happen, which is at this particular part. Okay, so yeah, and then this is the notes lah, where you provide the so I will release your assessment. Okay, I will ask you to do the example. You come up with the example, but I want, instead of 3 meter interval, I want you to come up with 2 meter interval, so you have more actually. Okay, more, so more calculation. All right, you can do either you can do in Excel, okay, in terms of formulating, or you can also do handwriting. It depends on your preference, which one that you want, which one you prefer. Okay, and then come up with also this table as well. Okay, just to give you some feeling or to test your understanding, either you can do or not. If you have any difficulties, then you can discuss it further later on. All right. Okay. Any questions so far? Soalan, Irunisa? Okay, no answer. Sakina, okay? Shafika, are you guys with me? Shahira, okay?
Yes, madam.
Okay, boleh?
Yeah, madam.
Right. Siapa lagi? Fitri, okay. Alhamdulillah. Who else? Aidil, okay?
Boleh.
Boleh ya? Aiman? Okay, so if everyone is okay, if no other question, I hope you guys are clear. All right. But of course, once you, because you didn't try it yet, so try and redo the examples. Then you would know, probably if you still have lack of understanding and all. Okay, so then we can discuss, or you can WhatsApp me personally to ask the detail. Okay. All right. So I think that's all from me. If there's no question, we end like 1 hour, because I target this to this example is actually memang take around 1 hour. I hope with the ample time given, because normally a bit rush when I try to combine the lecture and also the example. So I hope by doing it this way, like, you are more clearer in terms of how to design and share for share link lah, for to design for share link. Okay. If I think that's all from me. Okay, I'll be seeing you back, because I will be seeing you. Kejap ya. Alright, I'll be seeing you back again next week, inshallah. So I wish you Selamat Hari Raya, Azerbaijan, since that this is our last lecture.
Selamat Raya juga, Madam.
Since that this is our not really last lecture, but this will be our last time meeting before Raya kan. Raya will be insyaAllah next week. This week.
Madam.
Yeah.
Madam, I have a question.
Yes. Siapa ni? Fazlin Niza, ya.
Saya dengar minggu ni ada quiz Madam.
Oh yeah, okay. About that, the quiz has been postponed to next week.
Oh, okay.
Okay, the quiz has been postponed to next week, means I don't know, but I've been told by the coordinator they will have it next week. Maybe they want give you time to enjoy your Raya first kot, before tak ada stress kan. Okay. Alright, so enjoy your Raya. Okay, even though it's only one day, alright. Only one day kan Raya under our ni, but I think you guys deserve a celebration lah, after Ramadan, after we had our Ramadan, we kind of like cheer for Hari Raya. This is what our religion is, what we are aim for after Ramadan. So a little celebration, not too much, not too fancy, not too big, but at least something that we appreciate the Shawwal lah, insyaAllah. Okay, because under our condition kan, under our situation, we cannot have it as what we used to be, we used to do, okay, like before. Right. Stay safe everyone, take care, regards to your family. So I hope you guys have a vast celebration of Shawwal, insyaAllah. Okay, thank you very much.
Thank you, Madam. Selamat Hari Raya.
Selamat
Take
Raya.
care.
Thank you, Madam. Selamat Raya juga. Selamat banyak.
Maaf
Tapi
saya
saya minta
batin.
maaf juga.
Alright, take care semua.
Thank you, Madam.
Thank you. Thank you.